In this review video, we're going to be talking about solving equations. So before attempting this stuff, just make sure you're comfortable with manipulating equations, as in like subtracting 2 from both sides and things like that. All right, factoring, we've already talked about that in a review video, so you should be comfortable with factoring. All right, make sure you know the quadratic formula. This is something you want to have memorized. All right, so if you don't have that memorized, I'll figure out a way for you to memorize that because it's very, very useful. And then just generally working with square roots. All those things are going to factor into us being able to effectively solve equations. All right, so when we encounter an unknown quantity, we want to figure out what it is. All right, we're going to have this equal sign with some x, and we want to figure out what is the x that makes this thing true. All right, in mathematics, this often happens when we have an equation and we want to solve it. So if you see the word solve, it means you're trying to get down to x equals something. All right, so there's 2 different strategies that we learned. We're going to learn more kind of as the year progresses, but right now we really have just 2 types of equations we can solve. We have linears and quadratics. So linears look something like that. All right, this is just kind of an x with a number. Quadratics, now we have an x squared. All right, so as soon as you see that x squared, you know you're in the quadratic realm and not the linear realm. All right, so our strategy for solving linears is we just simplify both sides. So if we need to like expand or combine stuff, we do that first. We're going to move the x's to one side and the numbers to the other. So we kind of separate the x's from everything else. And then all we have to do is just divide to get our x. So linear strategy, just kind of move x's to one side and then divide. The quadratic strategy is much more involved there because we have 3 kind of different strategies just for solving quadratics. And I kind of put them in the method that I would try them in. So the first one is factoring. If I can break down my quadratic into factors, then I can solve much easier equations using the zero product property. We'll see that in an example. If I can't figure out how to factor mine, I'm going to say, can I use square roots? I can square roots if I have an x squared, and I take its square root, they cancel out, and I just get x. All right, so taking the square root of an x squared, very useful, but you can't do it for every problem. And if factoring, I can't make factoring work, if square roots don't work for that problem, then your last option is doing the quadratic formula. All right, this one, you just plug it into that formula. I'll write it again, right, but you should have it memorized. All right, this is a C, there. All right, so you should have that formula memorized. All right, and that's going to help you solve every quadratic. So you could literally use the quadratic formula for every single quadratic problem. It's just going to take you a lot longer. All right, so here's my first example. X squared equals x plus 12. All right, right away, I recognize there's an x squared. All right, so that automatically tells me this is a quadratic problem and not a linear problem. All right. Second thing I ask myself is it possible for me to use square roots in this problem? And because I have an x squared term and an x term, if I were to use a square root here, it's just going to make this part more complicated. So I can't do square roots either. All right. Which means my only real option is to factor. Or I could use the quadratic formula, but both of those require the same first step, and that's getting 0 on one side. So I'm going to subtract x, subtract 12 from both sides, and I get 0 on one side. So this is the really important part. I get 0 on one side. And now I try to factor this. All right, so x squared minus x minus 12, I'd have to add to -1 and multiply to -12. And that's possible with -4 and +3. All right, so I can factor this using the splitting method. Oops, there's an x after that, 3. And I'm doing this quickly because we covered factoring in a previous review video. Again, you might not be able to do it this quickly, but hopefully you can do it. And then this turns into x minus 4 times x plus 3. All right, so far we've moved 0 to one side. We figured out we can factor, so we break it down into factors. And here we use the zero product property. All right, the zero product property says if multiple things are being multiplied to give 0, I can break this up into 2 smaller equations where each of these is equal to 0. All right, so it takes this complicated equation with multiple pieces and just makes them simpler. Here I add 4, here I subtract 3. All right, so it just makes the actual equations you're solving at the end much simpler. All right, example 2. Again, right now I'm just not trying to do anything. I'm just analyzing what I see. I see just a single x with no x squared. So that tells me this should be a linear problem. Its chances once you start simplifying that an x squared kind of pops up. For right now, I'm thinking this is linear. So let's simplify it first by distributing this 4 in. 4x minus 12 equals 7x minus 6. All right, now I definitely see I have an equation with no x squareds. So this is linear. And when it's linear, I'm going to get the two x terms on the same side and the two numbers on the other side. And it's up to you which way you're going to go. I know if I subtract the 4x to this side, I'm not going to get a negative x, and that just might be something that's nice. So I'm going to subtract 4x from both sides. And because I moved the x's to the right, I'm going to move the numbers to the left. So I'm going to add 6 to both sides. All right, these are going to cancel, give me negative 6. These are going to cancel, give me positive 3x. And then when you're solving a linear, once you get the x on one side, now you just need to get rid of this 3. Right now 3 is being multiplied by x, so I divide by 3. I get negative 2. Yep. So linear equations are probably the most comfortable with ones you are with solving, but just making sure you don't kind of get confused about when you should be doing linear stuff versus when you should be doing quadratic stuff. You're just kind of looking at the equation, seeing what type of things you have to know what you should do. When you're looking at this equation, you might say, okay, well, I look at the x, I just see an x, so this looks like it's linear, but that x is in the parentheses where it's being squared, so that it's going to turn into an x squared. So this is a quadratic problem. So even though you don't see an x squared specifically, if you were to multiply all this out and simplify, an x squared would pop up. But I don't necessarily want to multiply all out because I always want to see, could I use a square root to help me? And I have just this kind of squared term here and no x term by itself. So this is my cue that I actually can use square roots for this problem. Right, how do I use square roots for this problem? I need to get this squared term by itself, so I can use square roots to cancel it out. So to get it by itself, first I'm going to add 18 to both sides. Right. This is where the square root method is a little bit different because it's the only quadratic method where I don't get 0 on one side. I now need to get rid of this 2. Right now 2 is being multiplied, so I divide everything by 2. Right. And now this is what I want to see if I'm trying to use square roots. I have something squared equals a number. And once I have this, I can take the square root of both sides because the square root and the square cancel out. All right, here's a real big thing to see if you remember. When you're doing the square root of both sides in an equation like this, what do you have to write in the next step? And the answer for that is whenever you take the square root of both sides in an equation, you have to put a plus or minus in front of that answer on the right. I guess there's kind of two different answers you can get when you take a square root like this. And now I want to add 3. I'm trying to get the x all by itself. So now x is all by itself. All right, this is not going to turn into plus or minus 6 because right now I don't know if this 3 is positive or negative. So I'm just going to keep them separate for now. But this ends up giving me two answers. I could do 3 plus 3 is 6. I could do 3 minus 3 is 0. And that gives me two answers. All right, so that's the square root method. You don't have to do the square root method. You could have FOILed this out. Oops. Distributed, combined like terms, oops. And then factored and everything from there. You could do this. It's just, you can see already it's kind of more steps than you'd have to do. So if you recognize you can use square roots, it just saves you a lot of time solving these quadratics. The only method we didn't cover in this video was the quadratic formula, but if you have that formula memorized, it's literally just plug and chug. You plug your numbers in, simplify it as much as you can, right? And I think you can do that if you made it to this point in the semester. For your review, just make sure you're practicing. Again, the good thing with the practice that you're doing now is it's not going to tell you a specific method to do. So you're just going to see a problem. You have to figure out, is this linear, is this quadratic? If it's linear, there's only one way you solve it. If it's quadratic, is it factoring? Is it square roots? Is it quadratic formula? So it's really a lot of intuition and kind of figuring out what you're doing when you're looking at a problem.